prediction would be that by year 2020, the landscape in combination of privacy, cybersecurity, information security, and these kind of things will probably change. I'm not sure how much and into which direction, but I'm pretty sure that there's going to be certain bets on artificial intelligence coming into play. And from my perspective, also new things coming into play like machine vision, which might affect the privacy issues, which we have already information on in the press and everywhere else, as well as information security, cybersecurity, and other things. So just to be sure on why I'm here to talk about this. So I actually happen to be involved with at least 3 companies. There are a bit more than here, but anyway. My main focus already for 15 years or more has been pretty much information security, which is Analytica. But also I've been partner and one of the founders for the company which I mentioned here. One of them is Client Services, and I'm going to tell you what it is and what does it do. Other one is for smart streets, so that's pretty much tells the name. Idea is making streets smarter. And the second 2 are the ones involved in machine vision and artificial intelligence. Okay? So the idea is fairly simple. In 1957, there was a conference back in Dartmouth, and then there was a prediction that within a 2 months' time, so within the summer, most of the artificial intelligence challenges were going to be solved. So all the translation issues, so we're going to have artificial intellect, and this is going to work out. Didn't work out that well. So it ended up in actually having an ice age for artificial intelligence. So this ice age kind of ended, let's see for how long, in 2011. And Google announced its major success in artificial intelligence and machine vision, the things they did, so how they used something called convolutional neural networks and deep learning to improve this technology. We ended up on this train by accident. And by train, it's pretty much literally. At that point, we had a customer, which was local railroad. And what they had was every day, more than 100 trains coming in across the border. Each train was to be stopped in the first station after the border. 15 people jumped out from the building next to the train, and they were inspectors. So using walkie-talkies, walking by the train, and telling, this is a wagon number 1, the number is like this, the defects are there, graffitis, these kind of things or not. The other guy on the other end was on the walkie-talkie. He was writing it down on paper, then faxing it over to the central system, where somebody retyped it in the system. And this whole process took 1 hour. It was not a great process, because it actually was not really safe. Putting a person next to a 60 to 80 ton wagon moving is not really a good idea. It's not really a great job as well, as you can imagine. Doesn't have too much of a perspective for the future. Okay, so we were approached by a local railroad, and they asked us to maybe try to solve the problem. We actually failed initially. So initially, we used some kind of pre-existing system. It turned out it doesn't work. And one of the reasons was the trains were coming in pretty much not like this wagon here. So they're quite dirty. Many of the numbers were written, without using any actual template. So somebody done it by hand. And there were very many different kind of other issues which we're facing as we were going. It took us another year, so to speak. So in 2012, by using what was supposed to be even not so cool at the moment, not yet, the hype was not yet there for artificial intelligence and machine vision. So we managed to solve this issue by deploying the technologies which were there and do automated inspections at high speed, without stopping the train, and all these kind of things. Okay? So this is one part of the background which we had with machine vision. No connection to information security at that point of time whatsoever. So after a year or so, we jumped into another project. So we went around saying, we were so successful, we solved this. Artificial intelligence and machine vision was gaining momentum. And we were in the forefront of something by accident, actually, which was becoming very, very popular. And we had solutions to solve this. So we were approached by a local municipality. And they said, we had a small issue. We want to build a cyclist road, but we have 2 options. Option A, going to the beach. Option B, going to the next village. Which one should we choose? Should we put it on this, on the one to the beach or one to the next village? What are people using right now? So can you count cyclists from the data, from the videos, or these kind of things? Of course we could, we decided. It turned out to be actually also, we had a couple of failures along the way and a couple of learnings. as we went as well. So first failure which we had was pretty simple. There's no way a computer can differentiate cyclists which is drawn on the tarmac versus actual cyclist. So you have to train them. You had to train the system to teach that this is not an actual cyclist. This is a bicycle, but it's not the bicycle as you expect to be a cyclist riding it, right? So second thing which we also had, we had this guy who we were quite pissed about, who ended up buying an ice cream, going to the camera which we installed over there, next to it, and starting eating ice cream over there. The issue with this guy was fairly simple. The way the system was built, you know, it was motion. Is there a bicycle in the picture? If there's a bicycle, +1, right? The guy eating ice cream means that, you know, he opens ice cream, right, motion, bicycle, +1. Then after a short period of time, you know, he picks up the ice cream, he brings it to his mouth. Motion, bicycle, +1, right? So ended up actually counting this guy for 300 or more times in the end of the day, right? So we solved this by adding motion detection and these kind of things as a solution. But now let's get back to the security point of this, right? So from our perspective, the artificial intelligence, the whole concept that you can train the system to do the tasks which are repeatable and which take human resource otherwise, actually is a really nice concept because you reduce human error. So it's kind of match made in heaven in this perspective. That's the whole idea here. And you get the images, you use information, use videos and these kind of things. So machine vision is not only about images. It's actually different kind of other things as well. It can be sound. These can be smells, right? This can be motion. These can be radar-based systems, lidar-based systems, so laser-based radars, all these other things which actually are working over there. So the capacity for artificial intelligence was fairly simple. You use it to identify something, right? Recognize what it is, and then make a decision. What should you do? So this is a very simple concept. Most of you probably have heard it, have seen it actually happening. So there are many, many ways how it can be used, okay? So the way it's being used as well, if you look at this, is you actually train the system. You don't pre-program stuff which should be happening. You feed in the training data, which means you train the system what a cyclist should look like, what a wagon should look like, what are the types of wagons and these kind of things. And then you end up having, you know, a system which is able to recognize based on its historical experience of the knowledge kind of thing on what it is it's looking at right now. So this is a fairly simple concept, but there are many actual security consequences to this as well, okay? As we're going to talk through this, I'm going to actually focus a bit more on the ideas and the concepts which might be relevant to how information security can be circumvented or privacy can be circumvented by using technologies, and what are the risks we should consider when we look at this, okay? So this, and I would probably, you know, make a prediction, which I'm not sure is going to become true, but anyway, we're going to see it. I think this is going to have a profound effect on the privacy, on information security and cybersecurity as we go around. So from security perspective, the match is not just made in heaven. There is a little bit of hell to it as well as we go with this, right? So you have to be careful how you use it, what you're going to do about it, okay? So if you look at this, we actually merge physical and virtual worlds. When you talk about information security, most of you are professionals in this area, know it's about protecting information, whether printed, spoken, digital, non-digital, whatever, right? Then you have a cybersecurity term right now, which is quite different, which says it's only the electronic information which you focus on, the systems and these kind of things. This is where cybersecurity comes in. So the machine vision and artificial intelligence actually has a capacity to merge these two worlds. It has a capacity to get information from one world and quite efficiently make it usable in another world. If you look at several examples, like for example, a patient card in a hospital. It's in paper, it's in archive, so you have to physically go there, you have to know how the archive is built to look for it, and you have to pick it out and take it out and you should see it. Once you digitalize it, it becomes a different story. If you just scan it, that means you have to use some kind of form of basic neural network, which is usually called OCR, optical character recognition, to actually identify things like, for example, what's written in it, to make it searchable. Once you make it searchable, you face quite different set of risks, right? Because it enables to search by name, to search by diagnosis, to do all the things which were not there before. So you were limited before in the physical world, and you become quite unlimited in the virtual world, right? So the idea is that you have to have it brings you the capacity to use this data, and it's not just scanning, it's going to be more examples. So we're going to talk about some of them as we go, okay? So let's start with very simple applications. One of them is the Captcha. The classical Captcha, as far as I know, it's been sold as a mechanism for security. It has been circumvented already a long time ago. So there are systems which can actually automatically recognize Captcha, type in the correct concept, correct requested word over there, and say, yeah, this should work. So it doesn't really work for the purpose it was built for. The purpose was to prevent an automated system, in most cases, to do some kind of registration or fill in some kind of application to make it human, right? But then, of course, Google came up with reCAPTCHA, or the basic concept that you actually add more things to it. You use artificial intelligence to improve it, to make it harder in a way, right, for somebody to fool the system. But at the same time, of course, as usually security does, it brings out usability issue. So we had a customer, for example, who said, we want to have this functionality of preventing automated systems doing a bidding on auction portal. Okay, so once we have a bid, we want to make sure, that there's not going to be automated system doing the bidding for the customer. Okay, so guys implemented reCAPTCHA, said this is the best thing at the moment in the market. It should solve your issues. Within 2 weeks, you get first complaint. I'm bidding for real estate, which costs a couple of $100,000 US dollars or euros or whatever, and I have to recognize where there are sausages among 6 images, and you get these complaints once in a while, right? So you get this concept of how these things happen, of course, and then there is always this momentum on the both sides. So there's always somebody who is catching somebody and somebody who doesn't want to get caught, or the other way around. There's always this game, your cat and mouse, who's going to be first. So that means that the trick about artificial intelligence, additionally, which is quite successfully used here by Google, for example, is to have the most of the data. That's one of the reasons. The company or the organization which has a lot of data, and by data in this case in machine vision and artificial intelligence, I mean the data which has been classified, the training set. So if you have 1 million images where somebody has said, there is a sausage on this image, you're pretty happy because it means you are ahead of any of your competitor who has only 100,000 images like this. You're more likely to be successful. You get these 95% instead of getting 92% of recognition. So Google uses this in a way as a mechanism to get better. I would bet that the other party, like hackers and these kind of guys, are able to use this also to do this recognition the same way, right? Make mistakes, do man-in-the-middle attacks as well in some cases, to get this data and to make new type of systems who can circumvent this. So there's going to be some more things coming in to play. So there used to be recognizing numbers, recognizing words, and you made it more complicated. You added background over there, you strike it through, or the other things. Then you added images over there. You analyze the mouse motion as a person actually does something on the site. But still, there's always this cat and mouse game. So that means there are going to be more and more challenges, going to be new things which we have to solve as we go. And this is just a simple OCR issue, right? So the idea is that that's only one of the things which we have here. Okay? The similar effect, if you look at translation. Most of you have received letters like this, I would guess, right? I have 10 million or 100 million or 150 million in my account, which there is no way I can get out of you without your help, my dear friend. There is a nice theory which was, I think, presented back in 2012 by one of the guys who said, I don't remember which company, sorry, who said that the letters are intentionally dumb. And the reason is very, very simple. The people who fall for them, it doesn't make sense if there is a smart person falling for the letter if he rejects the second step or he has to transfer some kind of money. So you make them intentionally dumb, so you get only the people who fall for them who are more likely to be successful in the next stage, right? So you do pre-classification of your customers. But then you get all these phishing attacks and all these kind of things. And this is not just machine vision, this is more about just artificial intelligence. Translation gives you the ability for them to look pretty much the way you would expect them to be in your language, right? So if you look at this, she did a sample here, translation from English to Spanish, for example. Not sure about the quality of Spanish, no Spanish speakers, sorry guys. But the idea is pretty much simple. So you can make it look more and more convincing. And you don't need to speak the language, right? So these things will actually work very, very simply. Then from translation as usage in artificial intelligence and risks coming from it, about localization and all the other things. So you're not safe anymore being representative of a small nation or small language, because it can be efficiently translated and people can have a conversation with you. With you probably noticing maybe there's something odd, but over time it's going to get better and better. So these things can come into play. The next thing here, this is an image of a Buk missile system, which supposedly was used to take down Malaysian Airlines plane over Ukraine, right? This image actually comes from the research done by Bellingcat. And the simple issue here is very, very simple. There are many more ways nowadays to do research on the internet on any specific target you have without just knowing the names and locations. You can use image-based search. You can use EXIF data. And all these things you can use, you can look for similar things in the images, right? So if you see one thing, you might be able to say, hey, but there are some other uses as well. This is a positive use kind of in a way, right? This was used for research. In the same way, when somebody does investigation in the company, when somebody does investigation, what's happening, right? So they might take, a Google Street View from the parking lot of your company, identify what kind of vehicles normally people drive, and then address whatever comes out as a phishing towards specific areas, towards interest you have. It's BMW, it's Ford, or something else. So who should we address it to? How should we make it interesting for the people to be able to create sustainable attacks? So there's a lot more information you can gain from this here. Yesterday, I think Mr. Mitnick was mentioning and showing an example of John McAfee, right, as a video, those who were here. And this is not artificial intelligence, but it can be, if you look at this. One of the failures in the process was the way he was easily found by some journalists, just putting out a picture of him and not deleting EXIF data. So which very precisely placed it at a certain location, a certain resort near the pool, right? So this was one of the experiences John McAfee had of unsuccessful kind of hiding once he was on the run. But it's not just EXIF data. You can do much more. You can use technology to identify the angle of the sun. You can use technology to identify the possible location, time of day. You can correlate to this weather conditions, and you can actually extract much more information from a very, very simple image. And this is the ability which you can use en masse. So it's not just you looking for a very single image, you can actually search for all the images nearby. And not just by location, but also by other data, which can be used. And you could do this, as I said, en masse as well. Okay? So simplification of search for image. It's already available to anyone. You can use Google, you go up, you upload your image, as I did yesterday. And I didn't even remember what was it. I mean, that was an old receiver I had back in the house. Google immediately identified correctly. It says it's Pioneer VSX 921. It gives you similar images. So you can do, and this technology is machine vision. This is the ability to process image to enable it to search for something very similar, right? So there are other things which might be in case. So it's also the same research approach which can be used here and many other things. Let's look at this from a different perspective. Let's look at this image, right? It's an image of a house. So if you would imagine, and I think we have all heard about the CCTV cameras being hacked, people talking about Internet of Things, and need to protect the Internet of Things devices and all the other things related to this. So how can you use them? Yes, you can use them to launch a DOS attack, right? So a huge DOS attack. But maybe there's more profitable use to them from the bad guy's perspective. How about using automation just to identify which house to go to, right? So you can add a value of things to automatically. You can say, hey, this is a TV. Approximate cost is going to be like this. So we can check this on Amazon if we want to. You can add things like, table is going to cost this. That table is bigger, nicer, so it must be more expensive, right? There's a receiver there, chandelier over there, MacBook Air, which is really hard to see by person, but it's very efficient for any algorithm to find it because it knows what does it look like. So one of the examples is just using this in a maybe a different way, which brings out a new set of risks because this is not just house. This can also be commercial environment, organizations, these kind of things we talk about. Okay. So once we have these examples of how this can be maybe used not in the best way, let's look at the other way. How people, on the other hand, are always trying to fool artificial intelligence, right? This is an example. This is a photo. I would guess it comes from Russia. Does anybody know why there is this marking on the license plate? Sorry? Yeah, but I mean, what you see there is I would say there is a plastic bag somewhere wrapped around the license plate. Any idea why? So let me tell you then, okay? Moscow uses, you have to pay for parking as in most places around the world, right? So the way it works in Moscow is very, very simple. There are vehicles driving by. They take pictures of all the vehicles standing next to the road. They know this is a zone A, you have to pay this amount of money. And it's not a big amount of money. It's like €1 per hour, $1 US per hour, or something like this. So what people do, and this does automatic recognition of license plates. So once you get out of your car, what you do, you go to the back of your car, you put something like this on the license plate, right? And this, I think, is Rolls-Royce or something like this, right? So that means a person with a Rolls-Royce doesn't want to pay $1 US per hour, which is a bit interesting, but it must be mentality. And the car which goes nearby, it cannot recognize license plate. You think it might make sense for a person to get out and remove this thing, right? Only if 50% of people do this, it gets really, really annoying. There's no way you can, this is kind of DOS attack on the system which is trying to get the money from the people who are parking the cars. Okay, so what happens? That means government becomes smarter. So we talked about in the last presentation, Anders was talking about how regulations and standardization follow the actual requirements. So government says this is forbidden, right? Then you come up with this. So talking about smartness of the people. Do you have any idea what this is and how does it work? So I had to read to figure it out, to be honest. This is just a magnet, electric magnet. So what you do, you put a license plate on top, and then over one symbol in your license plate, you put something metallic. What does it mean? It means if you drive with this fake kind of license plate or whatever you have put on top of this, if somebody stops you, you push a button, it drops off. Right? So fooling artificial intelligence is another way where people get really smart. So not just using it, not just using machine vision, not just using intelligence, but there are other ways to use it, do it as well. Other things, so we can get more things, right? So one of the other things which is very popular right now is a privacy issue. And privacy issue can be very personal. So somebody directs a drone next to your house, right, and spies on you, looks what you're doing, and these kind of things. Or it can be a same thing. It can be automated. So the drone just flies over and gets all the data. It sees where people go, what people do, all the other things, right? I think there is a technology, at least as a concept of technology, of drones being brought up in the sites where there is expected to be, for example, in Syria and other places where there's expected to be kind of bombing. So they don't prevent the bombing, but the idea is that they track all the vehicles in the area. As soon as bombing happens, the drone system immediately says, this is where the vehicle originated from. And there are 3 other vehicles who originated from this same place. So you know where they are at the moment. So kind of non-preventional, but maybe preventional for the second, maybe third bombing. And there can be also malicious use for that. It's not just, the nice and positive use. So there will be more and more risks coming from this as bad guys turn their eyes to this technology. As they figure out a way to do this as machine vision, artificial intelligence, en masse, to process a lot of data, to get information, right? And the lines sometimes get really blurry. And by blurry, I mean the concept of machine vision, artificial intelligence, privacy, advertising. So these kind of things, they get really tricky. So when do you want this to happen versus when you don't? When do you agree to this? When do you give consent? Or versus you don't, right? So next thing is, next example is actually, just a couple of hours of our guys on our team spent playing around. This is the result they got almost immediately. So it takes 2 hours on a mobile phone. So we can pretty well, I mean, with some errors, but still, we can actually identify objects as we drive in the car. We can go into more detail if we want to. We can train this to search for faces, to search for license plates. We can train this to search for many other things which you want to see as we go. And there is a potentially good use for that, as well as there is potentially not so great use for that, right? So there's always something you have to consider in these cases, right? So you can see, it recognizes traffic lights, persons. You can classify them down, for example, to police officers or to men, women, or older persons or children, and all these kind of things. So a bunch of different kind of issues. So you have to remember that it's not only video and images, which is machine vision. There's a lot more data which we are luckily giving out, right? We use a lot of different kind of sensors. We use fitness tracker applications. Many of you, as I've seen, also have either the, what was the name of the Apple phone, right? Not phone, but the Apple iWatch, yeah, right, and these kind of things. And these actually have also tricky implications for security. Your mobile phone knows quite well when you drive, when you walk, when you sleep, when you run. Where do you do this? So this is also can be processed in mass or can be used to identify certain things, which are very relevant. There are sound-based tracking. I think many of you heard last year, I think it was, the idea that in Google Store, on Android Store, it was possible to download applications which used sound you cannot hear to pinpoint you, to identify you. So application was using mic, and when you walked by a beacon somewhere in the store, it immediately identified you without you knowing it, so without your consent. That's a privacy issue. There are many things which can be used for that, right? And also another issue which is not so much machine vision, which is a bit different, is reverse anonymization of data. So ability to extract single person from large data set which was supposed to be anonymized, whether it's healthcare data or similar things. So one of the top concerns everybody has, faces, right? So we are pretty much worried about our faces being recognized and the privacy being breached in this way. And this is exactly what machine vision and artificial intelligence is capable of doing. So Minority Report idea of saying hi to Tom Cruise as he walks by advertising, it's quite possible with around 60 to 70% efficiency or accuracy at the moment. So I think 73% was the percentage rate which NT Labs, a St. Petersburg-based research company, did on the last Google competition. Then 2 months after they did this, their technology was used to put a camera in a metro in St. Petersburg, and based on the data gathered, identify Russian porn stars on their social network, just as they walked by in their everyday life, right? And these kind of things, or identify just people as they walked by. So 60, 70% efficiency is not like 100%, but it's not really great either, as you can imagine from your privacy perspective, because you're quite likely to be identified, right? Yeah. There's another thing about machine vision and artificial intelligence. The way we talk about the systems, the systems we build, the systems we want to use for our convenience, like driverless cars, as we discussed, right, which is one of the things which is most common. There's another security implication issue. What happened? Why did the crash happen? Why? How did it happen? Right? The tricky thing is, once you do a predefined programming, you say, if this happened, then you have to do this, if this, then you have to do this. It's easy to follow it back as well, to understand where did it fail in case something bad happens. Once you use neural networks, you use a training set to identify, hey, this is a vehicle, this is a wall, so you know they should never meet at a speed. If you change the training set and you retrain and you upload the new training set, then it becomes a bit tricky. Can you identify the actual reasons what happened and how did it happen, right? So this becomes an issue as well. So it's not just about hacking directly into the car, it's about just altering the training set, making the system think, you know, that this is okay. This is what it expects to be happening. And that becomes tricky to investigate as well, because it's not just, you know, hacking into the system. It's a bit different story. It's about altering the training set, the training data, to make it make different decisions. So let's look a little bit at what the future holds, right? I've been talking about different kind of examples and everything, so let's talk about something a bit more hopeful in a way, right? So the issue is not one-sided. Activity patterns are going to come in, so you're going to talk about different kind of lack of privacy in the end, which is going to be an issue, right? And if you put this in the hands of bad guys, and there's a tricky thing, as I said, is sometimes definition of what the bad guys is. Now it's blurring more and more, right? Advertising, governments, when do you think they're good guys, when do you think they're bad guys? So from security perspective, this becomes more and more pressing issue. And the customer is also very tricky, because the customer is all the 7 billion people in the world, each individually with its own preferences, right? So how many of you do think it would be okay to identify your face once you enter the shop you go to regularly, just to give you best offers? Anybody? Not really, right? Okay. How many of you think it's okay to do this once you cross the border? No? Nobody? Okay, but it's actually happening. I mean, this is, once you do it, it's actually happening. I had an incident in Abu Dhabi airport. I couldn't get through the automated system, right? I was using my passport, which has my photo, which has my fingerprints in it, so all the data needed to, and I cannot get through the system. It rejects me. So I have to go to the people, sitting to the bodyguards. They point the camera at me, it doesn't work either. They get really pissed, they start typing, looking for things. Okay, let's go. I went, and that was, after an 8-hour flight, I was not really in the best shape. But then once I was walking to the hotel, I was thinking, why did this happen? Then I figured, oh, there are headphones, on my neck. So they disrupt the ability of the system to see my face, because they're quite big, and it's really hard for the system to see where my face starts, where does it end. So I didn't take them off, so the system failed to identify my face versus the one which was in the passport. So I had to do manual processing in that case. Okay. There are other things which you talk about. So we talk about advertising, right? So this is simple extraction. I don't think you see much, but simple extraction from Google Photos, where, I do back up some photos too. There are other uses for this, if you look at this. So what we can add. Hey, he consumes alcohol. There's a bar over there, as you can see. Apparently likes motorcycles, so there's a guy in a helmet, so that must be the thing. Interest in ISO management systems. I don't know if you can see it, but it's an ISO certification by somebody. This is an iPhone screenshot, so he has an iPhone. Oh, he watches TV, so there's a TV over there. There are children here, okay, so these must maybe his children, or he knows somebody has children. And these all things can be very easily extracted from information you put out there. And the question is, how do you operate with this, right? There are many other options which are out there. Like one of them is, for example, patterns of movement. So there is a concept of knowing where do people go, what is a normal heat map. That's a concept which is used. And when people deviate from this heat map, when people go somewhere where normally no other people go. And this can have good use cases, like for security, as well as can have bad use cases, if you look at this, right? So you can actually identify patterns. There are some examples of people trying to identify what kind of PIN code you are entering on your ATM based on the small movements from the back, filmed from the back of a mobile phone, or from somebody far away with a actually powerful camera. So what kind of PIN code you enter on your ATM machine once you extract the money from that one, right? Expectations. So planning the route, like where does the bank vehicle goes? Guys who pick up the money from the ATMs. Where does it normally go? What's normal routes? How do they change it? Is there a pattern in the changes? Can we expect it to be at certain location, certain time? So this can be used as well. ITS systems, like intelligent traffic systems, if they get hacked, you get a lot of information, which might be very interesting. Who goes? Where do they go? What do they do? Right? Hey, this guy I know, this is a vehicle I know, this license plate I know. Hey, where is he going? Oh, he was supposed to be there, but he's not there right now, right? So you have privacy issues and these kind of things which might be happening. So security itself becomes much more personalized when you look at this, right? So you get all the other things which might be happening. Luckily, some of them are not there yet. Like there's, at least not to my knowledge. You can have, once you teach the computer to play games, for example, you can maybe at some point, if there's no additional ice age coming into artificial intelligence, which nobody can predict, you can actually also teach the system to adopt to the code. So you can create attacks which actually build on themselves, build on the failures. And if the main goal for the system is a benefit is you should break this system, you should break into the system or something, it can become self-morphing. It's not there yet, but I mean, at some point it might come. So this is one of the other things to say, right? You can introduce false patterns to the system. You can say, you can train it to wrong things, in a way efficiently creating a different type of denial of service attack, something you don't expect to be there straight away, right? Stock trading with machine learning, you can fool that one as well, to do something it's not supposed to do, to follow a trend which it wasn't supposed to be following, right? So it's not all that bad. I mean, as I said, some of these things, they're not there yet. Okay, but they might come, and luckily, when I did the research for this, I looked at this, and there were not so many uses yet, like bad uses of machine vision artificial intelligence. But I don't think it's going to be the same story in a year or 2 years or something like this. I think there are going to be more and more kind of bad use cases for this, and we have to identify them. We have to add them to the risk assessments we make, and we have to think about how to do this, right? So a couple of things which we should take into consideration. So how should we deal with this? We talk about IoT device security. You have a couple of guys talking about this. You have Graham talking about smart streets and smart cities, sorry, my bad. Smart cities in the end of the day. So securing these actual machine vision collection devices is one of the things which is rather important if you don't want them to be used for bad purposes. Creating awareness is a much more tricky thing. Creating awareness is easy among a group of people like you here. Most of you have some experience in information security. Yes, of course. I mean, it has to be secure. Still, we don't have to reuse the passwords or default passwords or whatever else comes to this, right? So we have to protect our privacy. It's not that easy when you talk about general population. So these examples will come. I mean, they will create a lot of news, most likely. But I'm not sure that all the news bring as much awareness as we expect to, because news usually end up, in 2 weeks or so, they are just done. Everybody forgot about what was on the news, and that's it so far. So continual awareness should be there, as well as physical environment decisions have to be made on what do you do, where do you put the things which are capable of gathering information, like machine vision information. How do you work with them? What kind of applications do you have? And are you sure there's no other application somebody else might have on the systems you might have, right? There are certain limitations also there. Like, I think it was recently published that the Moore's law of processing power increasing all the time has been broken, so it's not going to work, hopefully. So there's not unlimited capacity. There's certain limitations with the capacity we have. But at the same time, the machine vision, artificial intelligence systems become smarter, become more efficient. So they use GPUs and all the other things, and they become more able to run on many kind of devices. So that's something we should take into consideration. So when you look at this, right, technology, as we discussed, is pretty much as smart as people using it. And to finalize this, I'm going to use an example from one of our customers. So that was a customs in one of the borders, on one of the borders. And they implemented a cool system. So it was not a machine vision system. It was just a prediction system. Also artificial intelligence based, training the patterns, identifying which kind of cargo, like containers, we have to open, and which one are okay. It turned out, and the idea was very simple. So we reduced the risk of human error. Reduce the risk of human error doing something bad. But this being pretty far east, the problem which they faced in the end of the day was the system was failing after a year. And the question was why? I did a small research and turned out the process was very, very simple. Once the system was put in place, it took around 2 weeks for somebody to understand that, once the system flags a container to be opened, you go to the guy who shipped the container and say, there might be an issue, so, we should solve this somehow. And, people solved this, in a way they were used to. And, the customs officers, who were apparently not that honest, made a lot of money until after 3 months, the system started failing. Because the data they were saying that this container is okay was reused to train the system. So it was not able to identify the risky containers anymore. Right? So that's one of the tricky things on how people can use how people actually are the ones who are users of this technology we have, and people are the ones who have a say whether we use it for good or bad. And we have to take these things into consideration. Thank you.